Hey, this is Mr. J, and let's use this example to find the area and perimeter of what appears to be a right triangle. We'll verify that in just a moment. All right, so let's do that. Let's put us a right angle here. I'll give it away a little bit, but how do we do that? Remember, we've got to find the negative reciprocal of A to C and C to B. Okay, so let's start out by drawing a right triangle from C to B. So it looks like it runs right 3 and goes up 2. Next, let's draw us a right triangle from A to C. Looks like it runs right 4 and goes down 6. Okay, well, the great thing here is that we've already got the components of slope that we can use in a moment with the distance. All right, so remember, we're trying to find if these slopes are negative reciprocals. All right, so the slope M of what we got, AC, is going to be equal to what? Down 6, run right 4, which reduces to negative 3/2. And then we're going to look at the slope of, what we got, CB here, CB, and that's going to be 2/3. All right, 2/3. So negative 3/2 and 2/3, they have opposite signs in the reciprocals. So yes, they are perpendicular. So we know it's a right triangle. All right, and again, the great thing here is that we've got these components. When I say components, let's use the original distances here. Don't inadvertently use that right there, because that right there will mess up your distance calculator. Okay, so you've got these two sets of components right here that come from slope. All right, so let's find the distance of AC. So the distance of AC is simply going to be these components squared. So let's do 4 squared, which is 16, plus negative 36, which is negative 6 squared, which is 36. And so that right there is the square root of 52. Okay, well, we can reduce that a little bit, right? I think that there's a 4 and 13 in here. All right, so square root of 4 is 2. 13 is left over, so it looks like our final answer is that the distance of AC is 2√13 units in length. All right, so let's go find the distance of CB. Okay, so again, let's use the components. We've got 3 squared, which is 9, and we've got 2 squared, which is 4. So that right there is the square root of 13 units in length. All right, so in a moment, we're going to have to add these segments together and perimeter. Notice that the square root of 13 and square root of 13 is going to allow us to add those two coefficient up front and the 1 coefficient, right? So we'll be able to do that in a moment. Let's find the length of AB first. All right, so we're going to run right here. It looks like we're running right 7. So that's 7, and in this case we're going down a little bit less, so we're going down 4. So again, let's go find the components. I'm sorry, we got the components. We got negative 4 and we got 7 of the length. What do we got? AB here. So we got the distance of AB is going to be equal to, let's put the change in x first. 7 squared is 49. Negative 4 squared, right? Negative times negative is positive, and so we get 4 plus 1 is 50, 9 plus 6 is 15, so we get square root of 65. I believe square root of 65 is simplest form. All right, so let's go after perimeter first. So the perimeter of ABC, triangle ABC, is going to be equal to 2√13 plus 1√13 plus the square root of 65. So what is that? All right, so the final exact answer, no rounding required, is 2 plus 1 is 3 square root of 13 plus square root of 65 units. That is the length of the perimeter right there. So that is the exact answer. No questions asked. All right, so we got that. So let's finish up now with the area. So the area of triangle ABC is going to be equal to, all right, well, think about it. This right here is a height, right? That right there is a height. That right there can be a base. If we rotated that and sat that right there right along the x-axis, right, and everything, that would be the base, and that right there would be the height. So let's go back and figure that out. So the area is base times height divided by 2. So AC is the base. Let's go find AC. So here's AC. So that right there is the base. 2√13 times, what do we got? Square root 13, that right there is the height, times square root of 13, and it's all divided by 2. Okay, so here we go. Almost there. 2 times height 1 is 2. Root 13 times root 13. Anytime you multiply a number in a square root and everything, the number pops out. So we've got that like that right there divided by 2. And it looks like that those 2's right there will cancel, right? So the final answer in terms of area is going to be 13 units squared. Okay? So quick review, make sure you use your components and everything. That way we don't have to worry about using these points in the distance formula. We're drawing these right triangles. Make sure you use the components. Make sure you don't use any sort of simplified version that you're making a comparison to see if slopes are parallel or in this case perpendicular. And then just rock on and use your components. Make sure you remember you're always going to have positive numbers inside here. And remember that the square root 13 is the same, these roots have the same sort of addition and multiplication properties as exponents, right? So that lets us say that 2 plus 1 is 3 root 13. All right, simplest form right there, exact answer. And certainly that's a really good whole number answer there. Thanks.